In this video, we're going to go over how to graph trigonometric functions that have been translated. That means another word for translate is shift, and shifts can happen going left, right, up, and down. So for this lesson, we're going to be building off a lot of knowledge that you may have regarding how other types of functions can be shifted on a graph. So if you have not practiced shifting any type of functions like quadratics or cubics, I would recommend going back and finding another video to review that. So let's start by talking about something called a phase shift. A phase shift, in other words, is a horizontal shift, and those names can be used interchangeably. In your equation, a phase shift happens when you have a positive h, it would shift it to the left, and a negative h shifts it to the right. So it's actually the kind of the opposite of what you would think. When it's positive, it goes in the negative direction, and when it's negative, it goes in the positive. So if you're given the equation y equals a times sine of b quantity theta minus h plus k, the h part is what's moving our function left or right. So in this example, y equals sine of the quantity theta minus pi, our function is getting, the sine function in particular, is getting shifted pi units to the, and because it's negative, it's going to go to the right. In our next example, y equals cosine of the quantity theta plus pi over 4 shifts pi over 4 units. And since it's positive, it goes the opposite way of what you would think. It goes to the left. For vertical shifts, that happens when we add or subtract a value at the end. If you add a value, it will shift it up. If you subtract a value, it shifts it down. So k is usually, or the value you're adding or subtracting is typically written at the end, but you could rearrange this equation if you wanted. So y equals sine of theta minus 4 shifts 4 units down. Y equals cosine of theta plus 2 shifts 2 units up. So then we get, this is our final equation that we have for transforming trigonometric functions. Any trig function could be replaced by what we have here for sine. So we could, for instance, instead have tangent there, or cotangent, or cosecant, etc. As we're beginning to do shifts, I'm going to introduce you to a new vocabulary word called the midline. When we shift a graph vertically, we create a new horizontal axis. We call this a midline. This is the reference line to which a graph oscillates, or to which it increases above and below. It sort of keeps going up and down below this line. So let's start by thinking about where the midline is on the original sine function. The midline of the original sine function is our our x-axis, which is the line y equals 0. If you add 4 to the sine function, this entire graph is shifting upward. So your new midline is going to be 4 units higher than it was previously. So the midline of the graph, sine of theta plus 4, has a midline of y equals 4. Midlines can be helpful to graph, and you'll see this in some of our next examples, because they can help you think about points going above and below the graph at that midline. Another thing that can happen, and our last kind of transformation to talk about, is a reflection. A reflection happens when we have a negative amplitude, and it will reflect the graph over its midline. For the next examples, we're going to be trying to identify all of these different ways that we can transform our trigonometric functions. The 5 things that we think about are amplitude, period, phase shift, vertical shift, and midline for each function. Amplitude, if you can remember from our last couple of videos, is the number it gets multiplied by in the front. In example 2 here, the amplitude would be 1 over 2. Our period changes based on whatever type of function we have. Cosine typically has a period of 2 pi. We're going to divide that by whatever number is getting multiplied by theta. And we take its absolute value. In this case, 3 is positive, so I'm just going to write a 3. So 2 pi over 3 would be the period. That comes from this value here. A horizontal shift comes from a number being inside our parentheses for cosine and subtracted or added, similar to what you see in this example. Since that isn't happening here, we would just say no answer or none. Our vertical shifts happen from a number being added or subtracted at the end. So in this case, our vertical shift is -5 units or 5 units down, whichever you want to write. And if our shift has been 5 units and our typical, for cosine, the midline is typically our axis, our x-axis, that has now shifted down 5 units. And so our new midline is y equals -5. Here's a practice problem for you to try on your own. I would suggest pausing this video and giving it a try now. Let's go ahead and look at one more example. Example 3 here. For example 3 here, let's go ahead and look at one more example. In example 3, we're going to try to determine the same information, however this time we're being given the graph instead of the equation. I always find it most helpful to start by looking for my midline, because my midline is going to help me find all of these other things. So if we look where our minimum is and where our maximum, it goes from -2 to 4. So right in between those, we'd have a midline at y equals 1. So our midline is y equals 1. That meant that our graph had a shift of +1 units because it is either a sine or a cosine wave, and our midline went up 1, so our vertical shift must have been 1. From here, we can start to look for our amplitude. Our amplitude can be found by thinking about how much up and down from our midline our maximum and minimum values go. If we look at our maximum, it goes 1, 2, 3 units up, and our minimum goes 3 units down. So that means our amplitude must be 3. Next, we need to look at our period. For looking at period, you're going to choose a point and find where it becomes that point again. In this case, I'm going to start here at this maximum value. I'm going to look at how far on our x-axis the graph needs to travel before it reaches that same x value. So here is how far it had to travel to get back to that same repeating pattern, which went from 0 to pi units. So our period must be pi. The last thing that we're going to take a look at is phase shifts or horizontal shifts. Horizontal shifts are a little bit trickier to use when we're given a graph, because if you shift the graph far enough, it will land on top of itself. So that means that there's multiple equations, an infinite number actually, that could be shifted, but be the same equation as one that has not been shifted. So what we're going to try to do right now is write an equation without a shift if it is possible. Sometimes it might not be, but we're going to give it a try here. So we know that our equation has an amplitude of 3. It's starting at a value that is not 0 on our y-axis, and it's going in a wave. So we're going to say that this is a cosine function. Its period's been changed. So typically we get a period by doing 2 pi divided by some number that's next to our angle theta. That number in this case to get pi would have to be 2. So we're going to say cosine of 2 theta. So that changes our period here. The last thing that happened to the graph was that it was shifted up, so +1. In this case, we were able to write an equation for the graph that's given here without using a shift. Go ahead and tune into my next video to get some more practice with how to graph functions involving multiple types of transformations. Thanks for listening.